Thanks for having me back again at this conference. It's great to be here. I presented here last year as well on parallel programming and concurrency, and last year there was a heckler in the audience. So if any of you guys are going to heckle me, I am prepared and ready. So I have a script on one screen and my slides on the other. Hopefully I can manage the coordination correctly. So I'm kind of flying blind on what's over there, but hopefully it goes okay. So yesterday, Piotr gave a good talk on creating a legacy Rails application in one easy step. Like many people, I came to Ruby through Rails. I was doing these super repetitive PHP applications that were essentially PHP MyAdmin, but with a nicer user interface. Over the years, I wrote my fair share of embarrassing Ruby code, the Rails way. I think I wrote a gem called Act as God Object. I suffered through gigantic applications and began to ask myself why I was even using this damn thing in the first place. You know, once the test suite starts to take over an hour and a half, or you have 179 gems in the project, there's active record API calls consuming all the classes everywhere, and pretty much every other reason these Rails rescue project consultancies exist. You really have to evaluate your own choices. I mean, make no mistake, this talk is not about Rails in any way. This talk is about how I learned to fix that pain entirely. So it took me a long time to arrive here. I learned a lot of things along the way, and today I'm here to share my experience in the hopes of making everyone in this room better software engineers. My primary goal is to encourage all of you to rethink your application's architecture. This talk will cover a lot of ground, and unfortunately I cannot show as much code as I'd like, so please read my blog and other in-depth resources for more technical discussions. Instead, this talk will focus on the high-level concepts with minimal code examples. I don't think any of these ideas are new. Each stands on its own or on the shoulders of brilliant engineers. Hopefully, everyone's here of solid. We're lucky enough to have Michael Feathers somewhere here. Maybe he's here, maybe not so early, but he coined the mnemonic so all of us could remember the important things more easily. And it's also great that he's here because he can answer your questions about the material after my talk. So if you ask him a question, let me know and I'll buy him a beer for his technical support. So we have a slide about productivity, and I feel this is how most applications end up over time. Maybe it starts out okay in the beginning, you get going, you ship, and then eventually you end up in this place where you cannot function anymore. My goal is to get us into something like this, where we aren't burdened by all the weight of the previous technical decisions. We can continue to develop and release features over the course of an application's lifetime. In order to do this, we have to spend more time up front architecting and designing the application. Yes. Thank you. So this conference is about challenging ideas. I challenge the idea that the Ruby community knows and understands how to architect and design code bases. We do not respect solid principles, and I think on the level, the Ruby community produces programs that ignore fundamental architectural boundaries. This in turn creates more technical debt, which makes it harder for us to ship. This limits our capacity to meet ongoing business needs, lest we forget that this is our single responsibility principle. In order to address this problem, we need to start from the beginning to arrive at a position where the application contains proper boundaries and use of design patterns. I skipped those. So I think every application is generated in a big bang moment in our heads. There's a moment where everything comes together and poof, we can see how it should work and how it should be programmed. But we need to unpack the word application. I mean, what is an application? And what does everyone think when they start thinking about a new application? Is the first thought towards, like, oh my God, shiny, look at all the things I can do? Or is it, I can't wait to try out this new library? Or what framework should I use? If any of these things hit home for you, then I hope you can take away something from my talk. None of these things are actually important, and we must understand that an application is a collection of use cases, and that's it, regardless of anything else. Now, as web developers, we suffer from this thing that I like to call the bullshit onion, that there are so many things in front of us that prevent us from actually focusing on what we're supposed to deliver or what we're supposed to ship. Things like HTML, JavaScript, CSS, all of these things that are just anecdotes. These are all implementation details, but yet we pay so much attention to them. And just forget all of that shit. It's not important. You need to focus on the core of what we're supposed to be doing. And that's a use case. And a use case represents business logic. It takes input from the user and does something for them. It interacts with a host of other classes in the system to enact the desired change. That is the single responsibility principle at work. But what are the other classes? These are the domain entities, and they are the nouns in the system. There are also adjectives, verbs, and prepositions. And it's the use case's job to arrange all these different parts into a coherent sentence. And yeah, I put business logic on a pedestal because it is the most important thing that we need to be paying attention to. So I mentioned that use cases use input from the user and do something with it. Now we're faced with a question. How does that actually happen? Well, there's this thing, and it's called the delivery mechanism. It takes the domain classes and exposes them to the outside world in a way that a human can understand and interact with. As programmers, we think the best delivery mechanism is for the user to clone our repository, require a class, and call a method. However, this actually wasn't arcane enough, so the industry invented JavaScript, HTML, and CSS. In reality, the delivery mechanism is the boundary between the human interaction context and our domain logic. And there's the word boundary again. It's important, and we have to go deeper to understand its power. Boundaries separate larger application concerns. Each concern is another layer, and every application has at least two layers. There is the business logic layer and the data layer. Notice I did not include the UI because the UI is not important. The business logic can exist independent of any sort of presentation logic. Yes, actually, we are. Thanks for keeping me honest. It's my first time trying this arrangement, so it will be kinks. Yeah, so the business logic and the data layer. Now, these boundaries are extremely important because it enables different subsystems to vary independently of each other. This is to say that each side of the boundary can be replaced with another component, and the wider system is none the wiser. Aggressive boundary creation allows us to focus our efforts on more discrete units of code. This, in turn, increases our ability to estimate, change, and meet real engineering requirements. Hell, it might even make us happier. Now that the problem domain is smaller, it's easier for us to apply solid principles, design patterns, and use object rules. Let's turn our attention back to the application layer. What things live in there? Well, this is where all the magic happens. We know we have use cases and domain entities. Now, domain entities is a broad term on purpose because large systems contain many different types of classes and many different responsibilities. So it's hard to categorize everything. However, there are a few common use cases such as forms, validators, models, and repositories. Let's go on a quick tour of these objects. So, a form object collects and sanitizes and models system input. They are the boundary between the UI or the presentation layer or anything else and our application layer. They can do context-free validations such as, is a given value less than 100? They also coerce input into the right type, say converting a string from a console into an integer or you expect, or say parsing a gigantic JSON blob into an actual object that you use in your system. These are the border guards. A form object protects our system from the outside world. They should be strict and ruthless, since once the data passes through this boundary, it will never be checked in the wider system. Next up, we have models, which are simple classes. They encapsulate data and state. There's nothing fancy about this object. I think that we can all understand it. Now, if there are any Rails fanatics in the audience, and if you thought about active record here, I think that you definitely should stop that. And there's a much better way to approach these problems. And if you didn't think about active record, if you saw this and you thought to yourself, like, yeah, that's good, I like that, then perhaps you already know what's coming next. Now, unfortunately, it's hard for us programmers to think of data without considering persistence. I mean, after all, what good are the objects if we can manipulate them and we can't get them back again? Now, this is dangerous in my experience because we usually tend to focus precisely on how the data itself will be persisted rather than the boundary between the data access and the data persistence. I mean, we ask ourselves questions like, should I use an RDMS? Or what about a document store? Or key value? Or hell, maybe Elasticsearch can actually be my primary data store. All of these are important questions, but the important thing is to ask them at the appropriate time. And when we're thinking about modeling our data, we need to think in terms of these type of things, not in concretions. I mean, how many times have we committed to one solution too early, or realized we might need a different style of persistence for different kinds of data access? Perhaps some of our data could be persisted in RDMS, or part of it is easier to access via key value system like Redis. But committing to those decisions too early can be a mistake, or even using an ORM in the beginning and pushing up all of its concerns higher up into the application layer. All of these can be deadly mistakes. We have to learn to build on abstractions and not particular concretions. It's fitting that we arrive here, actually. How many of us have ever asked ourselves, how can I run my tests without the database? I mean, there's a well-known answer to this, and it's quite simple. And the answer is to introduce a boundary between data access and persistence. This is arguably the most important decoupling that you can do, and it was a turning point for me. Once I had my tests running against memory-style implementations, there was simply no going back. I realized that I could aggressively create more and more boundaries in my application to isolate it, to isolate my domain logic versus whatever sort of communication was doing with the outside world. If you're familiar with Haskell, this is basically impure versus pure. And I did all of this just because I wanted my tests fast in the beginning, but I realized what had actually empowered me to do was completely separate all the different concerns of my application. And it ended up with something that was basically a ports and adapter style application, which is how I do all of my applications today. I mean, decoupling is not just about fast tests. It also allows us to defer important decisions about our architecture, like the previous data store questions, until we have enough information to make the right decision. And Uncle Bob Martin states that this is the hallmark of good architecture. And there's a design pattern that fits the bill perfectly, and it's the repository pattern. Repositories are the interface to the underlying data layer. Here's Martin Fowler's definition. A repository mediates between domain and data mapping layers, acting like an in-memory object collection. Client objects construct query specifications declaratively and submit them to the repository for resolution. Objects can be added and removed from the repository as they can from a simple collection of objects, and the mapping code encapsulated by the repository will carry out the appropriate operations behind the scenes. Conceptually, a repository encapsulates the set of objects persisted in a data store and the operations performed over them, providing a more object-oriented view of the persistence layer. Most importantly, the repository also supports the objective of achieving a clean separation and one-way dependency between domain and data mapping layers. The most important thing to take away from that definition is the fact that it's a one-way dependency. A one-way dependency means it only flows one way. So the caller itself relies on the repository to do something. The repository itself will never call back up into a different layer. If there is communication back and forth, we could not call that a boundary. And you really couldn't ask for more from a pattern. So now that that's solved, it's time to move on to the next object. Validators implement more complex validations. They may require state or more complex business rules. Now, I know that you'd love me to probably pull out an example class from my hat of what a validator actually is, but as you can see, I don't have a hat on. It's hard for me to give you a concrete example of what this class actually is because it is domain-specific and application-specific. Earlier, I mentioned that forms can do context-free validations, such as, is the given value on it less than 100? That we don't need to know any other information. However, in practice, there are more complex things that we have to do, such as, do this if the user is this? Did they fill in this? Is the other thing this? There's all of these miscellaneous thises that might add up to some specific validation. This is an example of a more complex validation that can be modeled with a specific class. Now, just know that this role exists and it will eventually materialize in your application. Finally, use cases interact with all these objects to do something. They combine stateless domain entities with state and enact the required change. Now, state can actually mean anything, but in most cases, state is usually just who the current user is. Now, all of this information is simply passed in via the constructor. So the use case takes in a form and the state. So you can see def initialize form current user. Now, thank you. This is not working out as well as I'd hoped. Problem with Keynote is you can't have a gigantic script. So just to backtrack a little bit, we have an example of a repository with a simple interface to create and read any type of object. Now, what those class or objects is, it doesn't make any difference to us. We just take our objects and throw them over the wall, essentially the way that most of us throw our code over the wall to operations. Just, hey, you take care of it, right? But the important thing is you can see that the logic exists between those two methods. So naturally, we can swap it out with something like a SQL repository that takes tables and does things, or we can have a Redis type implementation that uses JSON to persist in Redis. And the important thing is that the logic is entirely encapsulated inside this class. And we can use this class in different cases or anything else. Like I mentioned earlier, it's important because the wider system is none the wiser about how these things are actually happening. So this is an example of a use case from one of my applications. It is a JSON API to serve an iOS app for sharing photos. So as you can see, this state is passed in via the constructor. This means these objects are easily testable. Pass in the form and state, and then assert on the results and any other possible side effects. I mean, This encourages a clean separation between what the system actually does and how the user interacts with it. This is especially important as systems grow because, well, requirements and things tend to get lost, and there's an intermingling between how things are presented versus what the system actually does. In my current company, there's so much entanglement that most people don't actually know what's supposed to happen. They just know what things are supposed to look like. So now we've gone all the way down to the bottom and come back up. I mentioned user interaction, and this is the delivery mechanism. Now I'm in sync again, cool. So this is the delivery mechanism. The delivery mechanism instantiates the forms, handles state management in its given medium, instantiates use cases, and then executes them, and displays the results in whatever way it makes sense for its particular medium. It also handles failure scenarios in a medium-appropriate way. I keep saying medium-appropriate way because we can have multiple delivery mechanisms. This is an example of a Sinatra route handler. So naturally, we all think in HTML and CSS or whatever. So maybe this one will display JSON. Maybe if there's an error, it will do some sort of flash message, right? But I say it's medium-specific because it's also possible for us to take the internals of this code and also extract it out into, say, a command line interface. And medium-specific way there could be standard out.putS or standard error.putS. There's a difference. So we can have multiple delivery mechanisms and we can interact with them in different ways because the actual application logic is decoupled from how it's presented. So we're left with two primary tiers. There's the user-facing application layer, which contains all of the business logic. Naturally, inside each, there are more responsibilities. The presentation layer will have a bunch of view objects for logicless templates, and it may even have serializers to power a JSON API. It will most likely have middleware to do God knows what, all the things that middleware do, and a bunch of other stuff to make its job easier, all isolated inside its particular class or module or namespace. Now, the application layer we know will contain a bunch of other objects such as forms, use cases, validators, repositories, and all sorts of other things, all the domain entities, all of the things that we actually makes our application work. The repository is a boundary between the domain objects and the data layer. Hopefully, all the dependencies on the outside world are replaced with boundaries. Need to talk to Twitter? There's a boundary there. What about sending email? There's a boundary. Most of us have probably already been exposed to this in some way without necessarily even noticing it. For example, in the beginning, if you're using Action Mailer, they have a test delivery method. So what does this do? It's the same interface, but it stores all of the delivered emails in an array, so you can look at them and assert that they came out or they looked a certain way. That's an example of a boundary at work. Now, all of these decisions come together in testing. Want to test your data layer? You can unit test that. Want fast tests? Swap the real implementations for fast memory style or fake implementations. Everything is decoupled and isolated. This puts us in a powerful position where we can leverage the O in solid. O means open for extension and closed for modification. So now it's possible for us to compose more complex flows or applications by reusing our existing domain entities. For example, when I worked on a CRM, I had a bunch of very complicated flows that were composed of different parts. I had one that was send an email. So the user would input an email address, and if the email address did not exist in our existing customer database, he would have to go through the use case of creating a customer and then sending an email. Since I had already created the create customer use case, inside send email, I could simply instantiate create customer and call it. And all of the things that happened, like all of the emails, all of the notifications could simply just be reused in different contexts. Try doing that with MVC. So I shamelessly took these slides from Uncle Bob Martin's talk on architecture of the lost years, because he's much better at making hand-drawn diagrams than I am. But it essentially covers most of the important things. His terminology is a little different. For example, he uses interactor where I use use case. The delivery mechanism is there, and boundary in my case might represent forms or whatever, but the principles are all there. So a user does something and something goes in across the delivery mechanism through the boundary. I think that he's a little bit more, like, I guess you could say enterprisey in this sort of way because there's request models and response models and things like that. But the important thing is the delivery mechanism handles instantiating this thing in a way that it knows how to, passes it through the boundary all the way down to the interactors or the use cases, which coordinate everything from validations, God knows what, all of the actual stuff to make the things happen. It comes back up through the boundary and then out to the user in some medium appropriate way. So why aren't more people doing this? I think there's many reasons. First of all, there are so many legacy applications that simply have to keep functioning, and it's not important for us to spend significant time refactoring them or updating them. Second is the fact that it's just goddamn hard to do this. Like, there's a lot more contextual overhead. There's a lot more things to consider. There's more upfront design. You have to be aware of these different concepts. You have to know about these different patterns. You perhaps have to have gone through the pain of not applying this stuff. It's just hard to do. I mean, third, I don't think the Ruby community actually encourages people to think like this. That's why I was happy to be given this opportunity to speak, so I could talk about this and hopefully make more people more aware of how to more separate their concerns to the applications. I mean, I think that the Ruby community encourages mindless over-reliance on gems and a bunch of other things. I mean, gems and frameworks, like for example, what we saw in the talk yesterday, we know that we can create this functionality through all these gems, but the answer is why? Why is it encouraged? Why do people think like that? And unfortunately, I think that that thinking is damaging to us long-term. And for those of us who have more experience working on larger applications, we have to communicate it to the other people who are just starting out that there is a different way to do these things. Yes, the guides or the documentation will tell you to do this, and it's nice in an introductory context, but in reality, it doesn't pan out in the long run. I mean, but all of this is not lost. I mean, we're all here today, and we're hopefully learning something. Now, I have two resources for you. The first up is Rails Refactoring by our lovable organizer over here, Andre. I was lucky enough to read a beta copy of the book, and I must say the content is fantastic. It provides a lot of very useful refactorings that you can do in a stepwise manner to decouple parts of your application to get you to a position where you can better apply these sort of architectural patterns. And he has this example with Simple Delegator. You have a controller, and it is the typical monolith, total junk drawer thing. And he does this thing with Simple Delegator it's just cool. I suggest you all check it out and read it and just ask him about it later. It really is great. Next, I will actually just toot my own horn because I have much more content about this stuff on my blog. I think it's 10 or 11 part series on all of this stuff. Very technical code examples, a lot of stuff, how to do everything. Now, the next one is also to my own horn, but I think that it's good because I have a 15-minute introductory screencast to how to actually start with a greenfield project, start from the very beginning stepwise by building up functionality just step at a time without doing any sort of ridiculous commitments to particular libraries or anything. There's actually there is one, but it's an example of how you can actually approach a project from a completely different mindset. So that's all I have to say. I hope that everybody learned something, and now if there's questions, fire away.
Thanks, Adam. So don't you think that one of the problems that we have in Ruby as a language is the lack of interfaces? So we can't, in a clear way, separate the boundaries. And the problem is that we don't know or don't have tools to deal with that easily.
Kind of. Because sometimes I want after doing Java, I know that I want to say like interface so and so and so. And that's nice because the compiler will tell you everything, but we can do it, we just have to give ourselves a little bit more like legwork to make it happen in the language. Like for example, to solve this problem now, I have a that uses the abstract type gem and some other things to say, okay, this is what this class should look like. And then basically I put a class like in front of that to say, okay, if this method is called, then if it doesn't respond to this fail with these sort of exceptions, then if it doesn't match this type signature. Sometimes it's unnecessary overhead, but I don't think that it's really such a problem. It just requires you to be more aware of the data you're passing in the type of signatures. But also that's why the testing is even more important. Like to combat this problem, I test those classes in isolation, but then in the whole integration test suite, I swap in the different objects to make sure there's no difference between how the things are implemented if perhaps like one returns a different type of object or receives another. So I don't think it's required at the language level. It just takes more legwork from us as programmers to ensure that all the objects are collaborating correctly.
Any more questions?
Oh.
Hi, good morning.
Good morning.
Yeah, excuse me for asking this, but is Rails productive or counterproductive in regards to this approach?
I feel that Rails is entirely counterproductive to anybody who I don't think, like, yes, like I kind of clap like internally for saying that, because in the beginning I was like, yes, Rails, like it's awesome, but now I look at it and just think to myself like that was a colossal mistake. The answer is I will not tell you, because that's what happens when, that's how Rails got here, because everybody said, hey, you use Rails, it is good. But the answer is to do the opposite, I think, of what the community tells you. It's you need to look through like perhaps the libraries or all the other things to find out what bits you actually want and then compose something from there. I mean, I think that the hardest part about all this is realizing at the end of the day, the hardest code you have to maintain is somebody else's code. So if you spend more time up front actually writing your own code, that thing can change and morph and do whatever. But even being too reliant on any number of libraries can be detrimental. So to sum it up, I think that you have to make your own decision. But the Rails is good for certain classes of applications, but when I do any sort of Ruby work now, I don't look to Rails to solve any of my use cases.
More questions? Who's next?
So first, hi.
Hey.
I like that principles, but it requires to create a lot of classes with single responsibility. That means that we have to create a lot of instances of these classes. And sometimes I heard opinion that in Java it's very expensive to create this instance. How is it in Ruby? Is it expensive or not?
Well, I don't know. That's a garbage collector thing, a language implementation detail, and I am just not equipped to answer that question. Perhaps there is a new book called Ruby Under the Microscope, which you can read, which gives a lot of detail into language specifically, so maybe there's some information there. Sorry, but I don't have the knowledge to answer your question.
Okay, it's fine, thanks.
Okay. Would you recommend this approach to every kind of project, or I don't know, early startups want?
No. I recommend this approach for people who are, or teams or whoever who is concerned with creating a long-term maintainable technical solution. That you can get going quickly here and do things that, I mean, you can get going fast. But part of the thing is that one of the reasons why I say that it's hard to do this is because to get to this point, perhaps you have to have failed a few times to realize that these are the actual abstractions that you need. But with more practice, maybe you can start here. But for example, certain very small class of applications, like maybe a blog, you don't need this. It's kind of, I'm not sure what the inflection point is where the complexity happens, but I think that there is a separation.
Why do you think this is connected strictly to race?
Huh?
I think this is not connected to race. This is connected to the race way, and I wish to sort of separate those two things. There's a way of doing things by default in race, and there's a gem called race, and it's a great piece of code.
Well, I think that's where you and I differ in opinion. That it is possible to separate the default Rails way from, say, the way that more experienced people use Rails. But if you look at all the things that make Rails more useful in terms of pushing your productivity level higher through use of gems and those sort of things, that like you demonstrated in your presentation, that on the level those can be more problematic. They can create more problems than they solve. And yes, it is possible, but it's trying to separate two things that really are together. Like DHH doesn't say that you should put callbacks in models, but the fact is that they put callbacks in models as functionality. Instead of just having something like before save, def save, do something, super. They encourage callbacks through design everywhere. And you have to be very vigilant in choosing not to use these things. And at some point, you just, what is it anymore? And I will say that the best part about Rails is actually the view helpers. Those are something I wish I had in more applications. But Active Record is really not as nice as an ORM. Action Dispatch is okay for handling HTTP, but it does not necessarily give you anything more useful than you get from Sinatra. And by using more of Rails, I think that people don't pay more attention to the underlying bits of the Ruby infrastructure that they should be using. For example, rack. I've met a lot of people who have no clue what rack middleware is or how these things actually work. They're just reliant on all the things that happen magically. So I don't think that it's a problem. I think that it is a problem with Rails, the entire Rails ecosystem. You can't necessarily separate the two because they are tightly coupled.
I got a question. You may be surprised, but maybe
Who?
right here.
Yeah.
So you might be surprised, but some percentage of this audience is sort of with you. I think you're sort of preaching to the choir. And I think I would raise a question is, assuming that we already do these in applications where we build use cases and stuff, you start wondering if the way Ruby is built as an object-oriented language where objects store state and behavior together, that you're sort of starting to combine, there's like this boundary that maybe we should start building across from this. So now that you started using use cases and stuff, do you also have this feeling that maybe sometimes we should start separating data from actual behavior?
No. Not yet. Now, by doing more of these style of applications, I realize that there are more extremely different infrastructure concerns. I mean, say, for example, part of this, say I have part of my application that should be written in an entirely different language. I'm thinking just more, or it should be scaled independently. I haven't really gotten to that point yet.
Last question.
Okay, hi. You mentioned this interesting repository pattern and that you use it in your applications. And do you recommend a particular gem for that, or do you just implement it every time yourself?
Well, naturally, I don't re-implement it every time. I will toot my own horn again for this, and I have my own project called Chassis, which is a collection of very small and lightweight modules, and one of them is an implementation of the repository. So in all of my projects, I use that. And I wouldn't consider that done yet because I'm still finding things that need to be changed in there. If you like, you can check it out, but the implementation is really nothing more than kind of what we had on the slides with some basic coordination between them. The thing with the repository pattern itself is it's very easy to create the interface. That's all that the pattern itself can do, but it's up to anybody who actually using it to provide the implementation. And that's where all of the work is. And I can't reuse that.
Thank you. Thank you very much. Great talk. Thanks, Adam.